Okay, let us see this simple trig proof, and then we see the else part. In most cases, when they give you the else part, it means you need just few steps to solve it. If you go past 7 steps, past 6, past 4, that means that you are not using an inner eye. So let's go through this. Prove that this is equal to this. Of course, I did the video for this for cos 30 theta. And of course, for sine 30 theta. Those videos are already there, but I'm going to go through it here so that I can handle this case part. The hint we use the double angle formula. We know that A, the multiple angle formula, how we expand the sine of A plus B. This is the case. Then we also know that sine, the double angle formula for sine. If you have sine 2 theta, then you have this angle or the sine. Then we know that from the first identity, cos squared plus sin squared is equal to 1. If you make the square the subject, you get this. Then you know that also the double angle, of course, is given by this. And you know now this is equal to this. When you put it there and simplify, that's what you get. Now, I'm going to consider this as the left-hand side and this as the right-hand side. So if I have this now, here, I'm going to expand this. You know that this is the same as sine 2 theta plus theta. If you add this, you go back there. Then I bring in this idea. I expand it in this order. So this is going to be now sine 2 theta sine theta. Now from there, I say double angle here. I also say double angle. I come for sine is this. Then for cos is this. So putting them there, I have now for sine 2 sine theta, cos theta. Then for cos 2 theta is here as 1. So here is that my task is to remove the side, the cos, because this proof for sine 3 theta is always in terms of sine. So even for cos, now you try to remove sine. But for this case, it's that I have only sine. That's why I'm trying to remove anything like cos and remain with the sine of a single angle. So in multiply here, is that I have 2 sine theta. Then this will give me cos squared theta. Then plus this times this. Then minus 2 sine cubed theta. So from there, I don't want this cos, so I remove it into now this cos squared sits there. I'm just giving many steps so that people can follow with ease. So now we multiply through this. We are going to be adding this times this, we get 2 sine theta. Then this side, this we get 2 sine cubed theta, then plus sine theta minus 2 sine cubed theta. And this way, when I simplify this and this, I have 3 sine theta, then negative and negative, I get minus 4 sine cubed theta with the is. This shows that our sine this theta is equal to that with is. So this is our part A. Then the hence part means where you've stopped is where you start from. And these are very easy. Hence solve this. Now, you look at what you have and what I want you to solve in the hence part. You see I have 8 and I have 6 and I have a 1. But here I don't have anything like 1. But I'm seeing this 6, when I multiply this by 2, I get this 6. When I multiply this by 2, I get this 8. So you first create, first of all, here 6 and here 8. But multiply both sides by 2. In part B, so my sine 3 theta is equal to 3 sine theta minus 4 sine cubed theta. Multiply both sides by 2. So multiply this side by 2. I have 2 sine equaling 2. By 2 here, I have 6 sine theta minus 8 sine cubed theta. What I multiply through by 2. Now, is that I have a 6 as in my hands, and I also have 8. But they are telling me this one is positive, and this one is negative. So what do? It's that they are letting them to be x. So that's what I'm also going to do first of all. So we say let x be sine theta. So here we have now 2 sine 30 theta equaling 6x minus 8x cubed. Now I think you can see that we are almost there. Now, you see that I have a 1 somewhere. So it means that now, and this is positive, so meaning I'm going to let 1 be equal to this. Then you say, let 2 sine 30 theta equaling to 6x minus 8x cubed be a 1. You see now, it means that this is also equal to 1, so that means that now 2 sine 30 theta is equal to 1 and 6x minus 8x cubed is equal to 1. Now it means that if I solve this, it's the same as solving this. So I think you can see our 8x cubed, I take them to the other side, plus 1 is equal to 0. But we have seen that if this is equal to this, and all of this is also equal to this. So this one is hard to solve. Okay, it's not hard to solve, but it's lengthy. But you can easily solve this. The values we get, because we have this in terms of x, and we get my x. So solving this is the same as solving this. So from there, now it's that my sine for this theta is going to be a half. So from here, my theta is going to be 30 degrees. That's the first quadrant. And then the second quadrant, 150 degrees. The first quadrant and second quadrant, because it's positive. And because they never gave me a range, now I consider this to be 0 degrees less 30 theta less 360 degrees. That's how I want to divide my range. But they told us to solve this. But now, if I have theta here, I can get my theta as 10 degrees, and then 50 degrees. But this was in x. I know that how x is related to theta, but I know that my x is equal to sine theta. I know that my x is going to be sine 10 degrees, comma, x is going to be sine 50 degrees. So from here, my x, the first value of x, is going to be, here I'm getting 0.1, 7, 3, 6, comma, another x value 0.7, 6, 6. Now, you see that this one is a cubic polynomial. Now, what does it imply? It implies that we have to be having the roots. But now, because I restricted my theta to be in these two, between 0 and this, the only angles you can get there are 2 angles. And now, if you consider theta to be this between 0 and 30, when you consider theta, so that means we had to go 3 times. Those 3 times, after going 3 times, you would have eliminated the sum and you'll be having 3 angles. But for now, may I just consider my theta to be there, so that my roots are going to be coming to 3 if you consider theta. Don't consider theta to be in that range. And so, that's how we handle it. As simple as that. Or, the other implication is, maybe you have a repeated root somewhere. You never know. Anyway, that's how we handle that. That's how we handle this. But the process is a bit lengthy just because of explanations. But it's very easy in that order. So, that's how we handle that question. wish you well. So you don't need to solve this because the all of this is equaling to this, and you see that when I solve this now, it's the same as me solving this. See you.